first video in a video series that will describe creating a Java application, a desktop application, that can be used to track volunteers. So throughout the video series, we're going to use things like JavaFX to create the GUIs. We're going to use traditional Java files to handle the model of our volunteers. And we use MySQL as a database to store information about volunteers. We're going to use two tables in MySQL, one to store information about the volunteers, such as what you see on the screen, like their first name, last name, birthday, photos, phone numbers, that kind of thing. And then we'll use another table to track their hours that they have volunteered. So let's get started. Oops, got a little residual stuff here. Let's just start from scratch. So I'll do a new project here. It's a Java application. I'm going to call it the volunteer app. Now, because we are using such a, we're going to be handling several files, because we're going to have our model files to describe our volunteers, but we're also going to have other things such as several different views, controllers for all the views. We're going to have images for all of our volunteers. So when you start looking at all those different things, you can see that we're going to have a lot of files. So if we put them all in one folder, it can be a little bit tough to manage, especially the images, because let's say we had thousands of volunteers. Well, all of a sudden, our volunteer images are all in the same folder as our actual program, and that could be problematic if we want to clean things up down the road. So what I'm going to do is under source packages, I'm going to say new Java package, and I'm going to create a few. I'm going to say models, and another package for the views, and another for the images. Now, you may say, well, if we're going to use a true MVC model, shouldn't we also have a package for the controllers? And the controllers and the views typically need to be in the same package. It just makes them run a little bit cleaner. So I'm going to click in the models area here. I'm going to say new Java class, and let's create our volunteer. Oops. Zoom in a little bit for everybody. Okay. So when we looked at our volunteer, these were the types of things that we thought we might want to track. So their first name, last name, the birthday, and that we may also want to validate to make sure they're within a certain age range. The idea of storing a photo, what we're going to do is we're actually going to store a file, so a link to a photo really, and a phone number. So let's build this out. So we always make our instance variables private. So first few would be strings. So first name, last name, and a phone number. We'll treat that as a string as well. Okay, so the reason I like to use local data objects is this takes into account time zones and locations and things like that. So it's a little bit more robust than the previous date class. And then the image file, instead of storing it as an image, which we could also do, I'm going to store it as a file, and that just makes it a lot cleaner to store it in the database. We can store the location of the file. Now, to speed up our coding efforts, most development environments include a lot of ways to speed things up. So I'm just going to right-click here and say Insert Code, and let's start with our constructor. So we'll create a constructor that accepts everything except for the image. And what I'm going to do here is these are all of these utilities or in each case here, the way the default scenario works is it will just put whatever's passed into our instance variables with no validation. And that's not really that useful. I mean, we want to make sure that we're given clean data before we instantiate the object. So the way I like to do this is I just create all the set birthday method, or sorry, set methods. And here I can insert code, getters and setters, and let's just select out those and say generate. And now the default naming convention will be set and then whatever the variable name is, right? So you can see it automatically created the first and last names. And I could put some validation on these, make sure they have uppercase letters to start, things like that. But what we haven't done here is we haven't dealt with this file object. So the way that we do that is we want to create a default image. Okay, so I've got a couple. Oops. A couple default images here. I'm just going to copy these. I'm going to move them into the directory that we created under images. Okay. So then here, what I'm going to do is I'm going to say set image file, and this will be a new file. And where I'm going to point it at is our src directory, which is where we start off in the root. So we're going to src, and we're going to images, and then let's choose the default person. Let's have a string. Okay. So by doing this, it allows us to have a constructor that does not require an actual image, but we just get the default image associated with the file. So, or sorry, the volunteer. So our default person. Why didn't that come up? Okay. Oh, we won't worry about showing you our default person just yet. Actually, we can look at it this way. It looks like this. Now, we may also have a constructor where we are given the person, in which case we can, again, go in here, insert code, of our constructor, select everything this time, say generate. And here's what's great. We don't have to, call all of these methods again. What we can do is we can say this. We can pass in all the same things as before. First name. Okay. So what this will do is it will call by saying this and then passing in first name, last name, phone number, birthday. It calls this constructor, which will set the image file to be the default. And then it'll come back here and it will override it with the actual image file. The nice thing is, by doing it this way, here we'll have a valid image file, and if we have an invalid one passed in, we can still deal with that and have a default. Okay. So there's certain things we might want to validate. So for example, phone numbers. With phone numbers, I'm going to suggest that it should match the North American dialing plan. So the North American dialing plan has a specific pattern. They call it NXX. And where this comes from, this was the area code. So there's certain patterns to these numbers. So for example, NXX, it can only, the N here, this represents that it can only be numbers 2 through 9. So 0 has a special significance because that's calling the operator. And 1 has a special significance because that's going to be long distance. But 2 through 9 are valid, valid numbers. And then the X means any number between 0 and 9. So as long as it starts with a 2 and then it has 2 numbers, and then we'll do a dash and 3 numbers and a dash and 4 numbers, that will be a valid phone number. So the way that we're going to do this is we're going to say if phone number matches, and here we're going to describe this pattern. So it matches, the first number has to be 2 through 9, and then we'll accept any digit. So that's what this //d is. That means any digit, and we need 2 of them. And then we can have a dash or not. So that's where the question mark means. So when you have, actually we'll put some brackets in here. So it could be dash or dot. Either of those is optional. And then again, we're going to say 3 digits. And then 4 digits. So if that's true, if the phone number falls within this pattern, then we'll set the phone number. Else, throw new. So the idea here is if we get an invalid phone number, don't keep creating the person, send some kind of information back. Like we're not going to create the person until we get a valid phone number. Similarly, with the birthday, we can validate that the person's within a certain age range. So in here we may say, we might want to know that the person's between 10 and 100 years old. Now we can always calculate a birthday, because if we know what year the person's born, and we can figure out the current year, then we can subtract the 2. But there's even a method that's a little more robust than that, a class. So we're going to use that. So let's do this. We'll say int age equals. This class period has a static method called between, and it will figure out the period between 2 dates. So if we put the birthday first, and today's date, what we can do is we could say get years. So it'll tell you how many whole years have passed between the birthday and today's date. Then we can just say, well, if the age is greater than or equal to 10, and the age is less than or equal to 100, this must be a valid volunteer. If not, we'll inform them. Okay, so that's a nice, elegant way to figure out someone's age and validate if we should set the birthday or not. Okay. So now we have a valid volunteer, right? We have a couple of constructors. We have the default constructor. We have get and set methods. We have some validation in here. The other thing that we should do is just create a toString method. So every class will inherit a toString method from the object class. But it doesn't really tell you much about the object, so it's better to override it. So in this case, we can say, this is a special method. If you don't explicitly call out toString, this is, and you try to print out an object's class information, this is what will come up. So here we'll say return string dot format All right. So let's test this out. Let's try to create a new volunteer. Set my memory here. So we have to give them a phone number. And a birth date. So we'll say local date. So March 10th, 2000. You see, it doesn't know our volunteer class. And based on some of our previous videos, you may be saying, well, what's with that? Like, how come it can't see it? But if we look, you know, it's because right now we're working in this class here, volunteer app. But really, we need to go into the models.volunteer, right? So they're in different packages. So what we're going to have to do is import that. So just going to left click here. Oh, do we have models? So we want the one called models. So there we have it. So now we have an instance of our class, and let's just print it to the screen. System.out.print. Okay, and down here we can see Fred Flintstone. He's 17 years old. All right, perfect. So now we have a model class, and we're able to instantiate the model class. In the next video, what we'll do is we'll look at how can we start creating ways in our model to write to a database, and we'll connect to a MySQL database. Thanks for watching this video.